Hi folks, welcome back to Physics with Captain Rod. The intention of this video here is to be example number 2 on how to find the centroid of a composite body. So what we're looking at here is we got this single piece of material here that's 6 feet high this way, 8 feet along this axis to this spot right here. It's got this circle cut out of it here, this half circle. So that's going to make this top geometry from here to here 8, 9, 10, 11 feet, and then same in the bottom. Then the idea here is how to find the centroid of this geometry that's kind of gray. So what I'm going to do first is put a coordinate system in. The very first thing we do, because the centroid is a set of coordinates, so you got to define, with respect to what origin and what direction. So I'm going to go ahead and put a coordinate system right here. X, Y in red. Now, because of the symmetry of the problem, I already know Y bar. This problem's symmetrical. We got the same area, same geometry, above the x-axis as we do below. So Y bar, I'm going to say is 0, and I'm just going to move on. I'll explain what this is here in a minute. Now, composite geometries here. We're going to decide how to handle this circle. And there's a couple different ways to handle this problem. What I'm going to do is I'm actually going to drop a line right here, and I'm going to outline in green what I'm going to call object 1. That's going to be my object 1. That's a very easy geometry to deal with. That's a rectangle 11 by 6. Centroid is at y equals 0, and the x bar here is going to be at 11 halves. And then I'm going to, in blue here, talk about my second object, which is going to be the circle, or I should say semicircle here. That's going to be my object 2. So again, green is object 1. Blue is object 2. And what I'm going to do here is I'm going to take off, I'm going to calculate a weighted average for x bar and y bar using the green and the blue. And what we're going to do here is we just need to subtract off the x bar for, we're treating this like this green minus the object in blue, and that's going to give us the object we want, this guy right here. What I'm going to do is demonstrate on table-wise how we handle that. So, just like before, in my previous video, I've got an object 1 and an object 2. I'm going to calculate x bar for each one, in area for each one. I'm not going to bother with y bar like I did in my previous video, because I know that y bar for the geometry is 0. Right, so object 1, again, that's the green one. X bar, let's see, is going to be 5.5 centimeters, because from here to here is 11, cutting that in half. I'm sorry, 5.5 feet. I'm just going to put 5.5, and again, these are going to be in feet. The area is going to be 11 by 6. That's going to be 66 square feet. I'll just put foot squared up here. All right, now we're going to talk about the semicircle here. So the semicircle, first we have to find the x bar for the semicircle. Now the center of area for a circle, and what I did is I went and looked this up because I didn't feel like deriving it for the video, but if I start here and I move this way, this distance right there is given by this expression, 4r over 3 pi. And in this example, see, that radius is 3 feet, so that's going to basically be 4 over pi. 1.27 feet. So from here to here is going to be, let's see, 11 minus 1.27. So the x bar here for our semicircle is 9.73 feet. And again, this is just something I looked up for this example. All right, now we're going to calculate the area. So the area of this rectangle, or I'm sorry, not rectangle, circle, let's see, pi r squared is the area of a whole circle, so I'm going to cut that in half, because we're looking at half a circle here. I get 14.13 square feet, and the way we take into account the fact that this thing isn't actually there is we use a negative area here, so this is going to be minus 14.13 square feet. Now to get x bar for this geometry, I'm going to take the x value for the rectangle, 5.5 feet, and multiply by 66 square feet. So this is now feet times square feet plus 9.73 feet times a negative 14.13 square feet. This product will now come out in cubic feet. And then we're going to just divide out the sum of the areas here. 66 plus a minus 14.13. And again, this will come out in feet. And like usual, just to try to keep the video short, I'm going to go ahead and pause this while I calculate this value. Okay, I'm back. So calculating the numerator, I got about 225.5 cubic feet up top, 51.87 square feet on the bottom for a weighted average of about 4.35 feet. Now, talk a little bit about, does that make sense in our problem? Well, imagine this were an 11 by 6. X bar would definitely be here at 5.5 feet. And then subtracting off some of this area definitely would drag that x bar over to the left some. So that 4.35 being a little bit, a reasonable way to the left of 5.5 feet, I think looks pretty good for the problem that we have. That's going to put that x bar maybe, I don't know, maybe right about there. And again, I'm doing that by eyeball. And again, what we have found here is technically called the center of area, but if this were a nice uniform geometry in both thickness and material, this is also the center of mass, meaning that that's where the gravitational force would go. So I hope this video helps demonstrate how to find the centroid of a composite geometry. Have a great day.